This season, we've decoded challenges, built connections, and pushed our limits to create a robot that's innovative, reliable, and ready to inspire. Last year, we finished 2 spots shy of Worlds, so we analyzed our setbacks and set clear goals for skills, outreach, fundraising, and robot performance, and created a team plan to achieve them.
Every team member, from leaders to designers, builders, drivers, scouts, coders, strategists, and first ambassadors, plays a key role. We all learn and contribute, ensuring our team thrives long term.
Christopher, a fourth-year mentor and former member, designed a summer training program teaching us important skills to help meet our personal goals. We covered robotics basics like kinematics, dynamics, algebra, trig, Java, and Roadrunner for path planning. Hands-on, we built, coded, and tuned the drivetrain, prepping our robot for autonomous navigation.
We connected deeply with the STEM community. 2 of us attended Worlds, surveying teams in the pits for tips on how to get there. A highlight to me and Dean Kamen, who personally requested mentors for First Global. Mentoring Team Cabo Verde on design, portfolio, and judging, we helped them jump 86 places. Making First loud on the world stage, we funded their award-winning video storytelling submission. They said that we were the team that has helped them the most, showing that our skills make a global impact.
We advocated nationally through SASA. Traveling to D.C. with a team-created flyer, we met personally with Senator Rick Scott and representatives from the offices of Florida and Georgia senators and congressmen seeking funding for the STEM via the NDAA. Having learned about the engineering design review process at Worlds, we partnered with 6 STEM professionals from Swiftland and Lockheed Martin, leading to 4 new mentors. We shared our designs and data, and the pros provided feedback. They taught us task management like this Kanban and real-time tracking. Our outreach sparked STEM interest far and wide. We surveyed our community, a STEM desert, to meet needs and increase access to STEM. Relationships built by volunteering at the food bank led to the distribution of 27 STEM kits and 25% of signups for our free 5-week FLL program at the library. Robot demos brought in another 45%. We've personally reached over 4,500 people. That's 8% of our county. Surveys showed 80% had never heard of First before meeting us. We've logged 680 plus man hours of outreach, 700 plus volunteering, including coaching 32 FLL kids, 30 new to First, fully funding and running the sandbots. Our social media, nearly 26,500 views. Due to our efforts, Florida's FTC kickoff included team-created tutorials, 2 of which were ours. We created a scouting app that 21 teams used and are the only team in Florida in the FTC Open Alliance. We're making First loud, recruiting new mentors and members. Sustainability is our foundation. We budgeted to fund us all the way to Worlds. Our goals included grants like DOD STEM and Gene Haas, sales at garage sales and makers markets, sponsorships, and discount cards. We've hit 100% for the season and states and 85% towards Worlds. We track everything, finances, projects, lessons learned to ensure we're here for future members.
Our engineering process starts at kickoff. Brainstorm, research, then narrow down ideas using tools like this pick chart for cost-benefit analysis and a weighted matrix for trade-off analysis. Focusing on ranking points, we set goals based on cycle times. Data drove changes like optimizing our innovative Spindexer.
Inspired by FRC's Infinite Recharge, we identified the Spindexer's ability to compactly store and ID artifacts while driving. Our unique lightweight 3D printed design snugly holds artifacts. An absolute position encoder tracks indexer position to within a half degree, which combined with 2 color sensors allows us to autonomously and reliably ID artifacts while intaking and driving. Artifacts are uniformly fed into the shooter by a flipper, providing smooth release. State machines use position feedback from the central rotor and flipper to lock actions until the indexer is aligned, mitigating the risks of jams and potential breaks. The Spindexer positively contributes to game objectives, scoring pattern points in auto and teleout, leading to wins in close matches and delivering 9 pattern ranking points in the 15 matches counted toward our ranking score.
Early season mathematical analysis focused on solving the kinematics of a launch artifact. We wrote a MATLAB script that simulated thousands of shots across varying launch angles and initial velocities. It plotted trajectories to verify they passed through the goal's opening, generating these insightful plots of viable shots from specific locations, which helped us perform a trade-off analysis between shooting from the near and far launch zones. While the far zone was closer to our human player and secret tunnel, the near zone allowed for consistent lower power shots.
Because our first hooded flywheel shooter was loud and inconsistent, we solved its dynamics by analyzing the kinetic energy in the wheel and artifact before and after launching. We derived an equation to predict flywheel recovery time. We improved consistency by choosing larger diameter wheels, allowing reduced flywheel speed, creating a higher moment of inertia, and decreasing the velocity drop between shots. Reduced flywheel speed and the removal of 3D printed helical bevel gears led to quieter operation.
Our robot is built for reliability and easy maintenance with a modular design. Elegant side panels provide a robust mounting point for number signs, protect internal components, and keep stray artifacts out. Protecting the mechanism wheels. They provide support for the drive axle, which lock in place with spacers, providing redundant constraints if set screws loosen. To navigate autonomously and improve driver control, we use Roadrunner path planning software with 2 dead wheel odometry pods and a Go Build a Pinpoint odometry computer.